Okay, so now today we're going to do carbohydrates. So carbohydrates can be split into the simple ones, and they are monosaccharides or disaccharides, and then you've got the complex carbohydrates, and they are your starch, glycogen, and cellulose. Okay, now the simple ones, the monosaccharides, they're what we're going to start with. So that's glucose, galactose, fructose, ribose, deoxyribose, things like that. So let's start with those. So there are two types of glucose. There's alpha glucose and there's beta glucose. Now the basic shape is the same. They are both 6-carbon hexose sugars. Hexose because they have 6 carbons. Okay, so we start with an oxygen. It has a kind of a hex kind of a shape. Now when you draw something like this, what this is saying is that at every one of these corners you've got a carbon. So you can draw in those carbons if you want to, but it gets quite complex. Now coming off that carbon you've got other groups. Now when I draw lines like this is above the plane of that ring. Get rid of that for a minute. So if this ring shape is that but flat, then this one pokes up above the plane of the ring, this one goes down below the plane of the ring. So on this first carbon, so this is carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5. So what this means is we've got something going above the plane of the ring, we've got something going below the plane of the ring. Now I said it was 6 carbons, and we've got 5 in the ring. The 6th carbon is outside of the ring, and it has something attached to it as well. Now alpha glucose is, well, the way I remember it is if you draw A for alpha and put a tail on your A, the OH on carbon 1, so on the first carbon, is below the plane of the ring, which means above the plane of the ring you've got hydrogen. On the second one it's also OH and H, and then they alternate. And you'd have another hydrogen there if you wanted to. Okay, so that's alpha glucose. Now the only difference between this one and beta glucose is this first carbon. So if we swap these around, we've then made beta glucose. Okay, so the way to remember it, alpha glucose has the OH below the plane of the ring, beta glucose has the OH above the plane of the ring. Okay, so that's glucose. The other ones you need to know are, so you need to know alpha glucose, beta glucose. Galactose is very similar to glucose. You have that CH2OH up there. But on this carbon, carbon 4, the OH and the H are the other way around. So on alpha glucose, it's below, and on galactose, it's above. Okay? So they are 3 hexose sugars. They are the 6 carbon sugars. Now you need to know an example of a 5-carbon sugar. And the 5-carbon sugar you need to know an example of is ribose. So 5 carbon, that is ribose. And because it's a 5-carbon, it is a pentose sugar. So we start with an oxygen at the top, and it does have a 5-sided shape, but it also has 5 carbons. So if we count these carbons, you've got 1, 2, 3, 4, and again, your 5th carbon is outside of the ring. It sticks up above the plane of the ring. And the rest are kind of similar. Now, ribose has 2 OHs down here. If it was deoxyribose, you'd be minus an oxygen, deoxy. Now, you are not expected to know deoxyribose, you are expected to know ribose, but if you know ribose, then you know deoxyribose as well. Okay, so they're the sugars you are expected to know. Now, one thing they can do is they could give you ribose, or they could give you fructose. Now, fructose looks very similar to ribose, but it has a 6th carbon. So it has 4 carbons in the ring, and then it has 2 carbons outside of the ring. So please always count your carbons. If there's 5 carbons, it's a pentose. If there's 6 carbons, it's a hexose. And the only kind of real difference, I don't know where you find them, the biggest difference between deoxyribose, ribose, and then fructose is that fructose has 6 carbons. So count your carbons. Okay. Now, the test for sugars is Benedict's solution, or Benedict's reagent. So you add Benedict's, you heat, and you will get a coloured precipitate. Okay, now those colours can change. So my pen's running out slightly. So if you get a coloured precipitate, then you have got what's called a reducing sugar. Now, there's a lot of confusion about reducing sugars. Essentially, inside Benedict's solution, Benedict's reagent, you have copper 2+. Now, if copper 2+ accepts an electron, it will be reduced to copper+. Okay, so inside Benedict's you have that. Those electrons have got to come from something in order to reduce. Reduction is accepting electrons. Now, in monosaccharides and in some of the disaccharides, they are able to donate electrons. So all monosaccharides and some disaccharides are able to donate electrons. So they are known as reducing sugars. Okay, so they are able to donate electrons to copper in order to produce this coloured precipitate, which can be green, it can be yellow, it can be orange, or brick red. And actually, the more sugar you have, the further down that scale you go. Okay, so these sugars, these monosaccharides and some of the disaccharides, are reducing sugars. They are able to reduce the copper in Benedict's solution. Now, there are other sugars which are non-reducing sugars. So let's have a look at those. So sucrose, for example, is a non-reducing sugar. Now, in a different video, I'm going to go through condensation and hydrolysis reactions, but essentially, if you have 2 sugars bonded together, so if this is sucrose, you've got 2 monosaccharides bonded together, and when you do that, these are no longer able to donate electrons. So this is a non-reducing sugar. So if you test with Benedict's, you will not get a coloured precipitate. Now, what you can do is hydrolyse it. If you hydrolyse it, you break that bond. So hydrolysis, you can use an enzyme, but you can heat it with hydrochloric acid, then you neutralise it, if I can spell neutralise, and what that does is it breaks that bond. Okay? Now, if you break that bond, you've got 2 monosaccharides, and all monosaccharides are reducing sugar. So you do Benedict's, you get a negative result. You hydrolyse, and then you redo Benedict's, and you will get a positive result because you've broken that bond. Okay? So you've got alpha glucose, beta glucose, ribose. They are all reducing sugars. So if you add Benedict and heat it, you'll get a coloured precipitate. If you have a disaccharide such as sucrose, it's a non-reducing sugar. So if you do Benedict, you won't get a positive result. But if you hydrolyse it to break the bond, redo Benedict, you will get a positive result. Okay? Right. So I'm going to go through how to do colorimetry in the next video.